So today, guys, we are going to start Unit 4. So we're going to do the first lesson, Unit 4, which is solving systems by graphing. We're going to be looking at systems of equations and what we call systems of inequalities. So let's actually define a system of equations first. So looking a little bit further down on the page, see that box right in the middle of the page? Let's read what it says. Two or more linear equations form a system of linear equations. So a system of linear equations is when we have two or more equations put together. We know what a linear equation is. It's just one. If we have two or more linear equations together, it's called a system of equations. Okay? Any ordered pair that makes all of the equations in a system true is a solution of a system of linear equations. So a system of linear equations is two or more linear equations put together. The solution to them, when we solve for x and y, has to make both statements true. Okay, and I'll show you what I mean when we actually start graphing them. So today, we're going to just solve these systems by graphing. So we're going to do problem 1 together. What is a solution to the system? And then we're going to check our answer. So before we even start, let's make our x and y axis. I'm going to use different colors. If you don't have different colors, that's fine. The thing about graphing a system, so when we're graphing more than one linear equation together, the solution is where they cross. So you need to make sure that your graphs are straight, that you are extending them all of the way, and that you're graphing them so that you can tell where the intersection point is. So my suggestion is that you use the side of your book, your binder, a notebook, or I have a couple rulers up here at the front to help graph. So if you need a ruler, come get one right now. So this is actually going to be really good review for graphing linear equations for us. So let's take a look at the first one. Y equals 2x plus 4. That is in slope-intercept form. What is my y-intercept? 4. So do a point at 4. 1, 2, 3, 4. What is the slope? 2. So that's 2 over 1. So from that point, I'm going to go up 2 over 1. And I would really like you guys to graph 3 points to make sure your graphs are super accurate. So from that 4, I also can go down to left 1. So negative 2 over negative 1 still reduces to positive 2. So let's connect those 3 points with a line. Make sure you extend the graph all the way. So it should look like that. Okay. The next one is y equals x plus 2. What's the y-intercept there? 2. So at positive 2. And then what's the slope? 1. That's positive 1 over positive 1. So you go up 1, right 1. And then from that point, you can go up 1, right 1 again. From the y-intercept, you also could have gone down 1, left 1. That works as well. Okay? But let's connect all those points with a line. Okay, guys, how many times do these graphs cross each other? Once, right? It should be at or almost right on the point negative 2, 0. So we are saying that the point negative 2, 0 is our solution. Okay, because that's where the two graphs cross. Back to our definition, it says that a solution of a system of linear equations is an ordered pair that makes all of the equations true. So that means if I were to plug in negative 2, 0 to the first equation, it's a true statement, and negative 2, 0 to the second equation, I should still get a true statement. So let's actually check our answer. So off to the side, let's check it. Okay, y equals 2x plus 4. What's the y coordinate? 0 equals 2 times negative 2 plus 4. So 0 equals negative 4 plus 4. Is negative 4 plus 4 0? Yes, so it works for that one. So I just put a check mark next to it. Now, it does not count if it only works for one. It has to work for both. So I'm going to plug it into the other one. 0 equals negative 2 plus 2. And what's negative 2 plus 2? 0. So I put a check next to that. So that is the right answer. It should make sense because this point lies on the purple line and it also lies on the pink line, right? So they have that point in common. So it should make both statements true. If you get a point that is true for one but not true for the other, it is not a solution, okay? How many times do you think two lines will ever cross each other? Just one, okay? So on the next side, I'm going to have you guys do numbers 1 and 2 together. I'm sorry, by yourselves. You can work together. Just as a hint for you, look at the graph or the first equation for number 1, 2x. Is there a y-intercept there?
Yeah. Isn't it plus 0?
It's plus 0. So you can do plus 0, okay? As a recommendation, probably on both of these, you will need to do your scale by 2s. So each line represents 2 points, okay? Okay, for number 1, y equals 2x plus 0. The y-intercept is 0. My slope is 2, which is 2 over 1. So I'm going to go up 2 over 1. But I am not super confident in my ability to put that exactly in the middle. So I'm going to do a third point. Up 2 over 1. And then I'm going to connect those with a line. Okay, so far so good? Okay. Okay, for the second equation, my y-intercept is 8, so 2, 4, 6, 8, and my slope is negative 2 over 1. So that means I'm going to go down 2, right 1. And the same thing, I'm not super confident with my ability to graph right in the middle, so I'm going to do it again. Down 2, right 1. Okay, where do they intersect, guys?
4, 2.
At 2, 4. So the solution is the point 2, 4. Do you have to put parentheses around them? Yes. Do you have to put a comma in between? Yes, they are an ordered pair. So they go together. To check your answer, you plug in 2, 4 to the first equation and 2, 4 to the second equation. So, really quick. For my check, y, which is 4, equals 2 times 2. Good? Yeah. The second one, y, which is 4, equals negative 2 times 2 plus 8. So that's 4 equals negative 4 plus 8. What's negative 4 plus 8? 4. So it works. Okay? All right, with the next one, the y-intercept is 7. So I'm going to go up 2, 4, 6, and then 7 is halfway between 6 and 8. My slope is positive 1/2, so my rise is 1, my run is 2. And then I'm going to do the same thing again, so up 1 over 2. So that gives me a line that looks like this. Okay, my second one, the y-intercept is 3, which is in between 2 and 4. My rise is 3, so I'm going to go up 1, 2, 3, and the run is 2, so just over 1 space. And then I'm going to do the exact same thing. 1, 2, 3 over 2. At what point do the two lines intersect there? 4, 9. So the point is 4, 9. Okay. To check it, you plug 4, 9 in. All right. For problem 2, we are going to take a word problem and write it into a system of equations. So, what I do for these is I first read the whole word problem. I define my variables, so x equals whatever, y equals whatever. And then pretty much for these word problems, you can go sentence by sentence. So one sentence will give you the first equation, and then the next sentence will usually give you the second equation. So let's read problem 2. One satellite radio service charges $10 per month plus an activation fee of $20. A second service charges $11 per month plus an activation fee of $15. In what month was the cost of both services the same? So our two variables, x and y, I'm going to let x equal the number of months. So make sure you write this down. And y is going to be the total cost. Okay. So let's first write an equation for the first satellite radio. So here's what I want you guys to do. Let's first underline. They charge $10 per month, and then under squiggle line plus an activation fee of $20. So guys, how would I write that as an equation?
10x.
Y equals?
Y equals 10x plus 20.
Good. Okay, so let's break this down really quick before we continue any further. 20 represents what in terms of the problem?
Y-intercept.
It's the y-intercept. That's in terms of the graph. What about in terms of the problem?
The activation fee.
The activation fee, which is how much you are paying no matter what, right? You're going to, no matter how many months you use it, you are still going to pay $20 to get that thing activated. We call that the initial value. Initial cost, initial value, same thing, okay? What about 10? What does 10 represent?
The money per month.
The how much money per month, which is your rate of change, which is your slope in terms of the graph, right? Okay, what I want you guys to do is right now, really quick, write the equation, the second equation for me. Okay, guys, who wants to tell me what the next equation would be? Maddie.
Y equals less than x.
You guys agree?
Yeah.
What is the initial value in this one? 15. What is the rate of change? 11. Okay, good. So there's your system of equations. The next question was, in what month was the cost of both services the same? So we have two options here. We can graph it, but when we tried graphing it in second period, it all goes all crazy because our rate of change is 10, our y-intercept is 20, and then all these other ones. So let's kind of think about what's going on here. If I have one service and a second service, and I want to know when they are the same, what could I do to those equations? What mathematical operation says that two things are the same? What symbol? Equals. So if I have this equation equal to this equation, could I figure out when they are the same? Yeah, so let's set them equal to each other. 10x plus 20 equals 11x plus 15. So this is saying satellite radio number 1 is equal to satellite radio number 2 at x months. So we just solve for x. So I'm going to subtract 10 from both sides. So that's 20 equals x plus 15. And then what would I do? Subtract 15. So I get x equals what? 5. So at the 5th month, they cost the same. And then one overtakes the other. Okay? Not too bad? You could also have solved this by guessing and checking in your head. For right now, that's also okay. All right? Okay, so here's what I want to do. Try 3 and 4. Number 3 is slightly different than what we've done, so make sure you define your variables. Number 4 is almost identical to what we just did, okay? So 4 should be super easy. 3 might be a little bit more challenging, but I want you to try them first on your own. Okay, guys, number 3. Number 3 says that the number of right-handed students in a math class is 9 times the number of left-handed students. The total number of students in the class is 30. How many right-handed students are in the class? How many left-handed students are in the class? I started by saying X is the number of right-handed students and Y is the number of left-handed students. Is everybody good with that?
Yeah.
Okay, so then let's read the sentence again. The number of right-handed students is, what does the word is mean?
Equal.
Equal. So let's start there. What variable is the number of right-handed students? X. So I have X is equals 9 times the number of left-handed students. 9 Y.
Wow. Oh.
That's an equation.
Wait, should it be backwards?
No, because X is the number of right-handed students. Y is the number of left-handed students. If you flip-flopped these, then yes, you would flip-flop those.
Okay, yeah, that's what
Okay? So if you said X is the number of left-handers and Y is the number of right-handers, you would get Y equals 9X. Okay, but you have to specify. If you tell me that X is the right-handed students and Y is the left-handed students, but you give me Y equals 9X, that's wrong. Okay, so you have to make sure your variables match up to what you said they do. So since I let X equal the number of right-handed students, and it says that the number of right-handed students is 9 times the number of left-handed students, that's X equals 9Y. Does that make sense? So you have to make sure your variables are matching up. So what would I do for my second equation? It says the total number of students is 30. In a class of 30, you're only going to have right-handed students or left-handed students. So if I have X right-handed students and Y left-handed students, and they total up to 30, how would I put that as an equation?
Y equals 30 right aside X.
Oh, you guys are making it way more complicated than that.
X equals...
The number of right-handed students plus the number of left-handed students is 30, right? Because that should make sense that if I ask you if you are right-handed or left-handed, everybody will only answer one kind, right? Irrelevant to the problem. Okay? All right, so then how'd you guys figure it out?
Guessing.
Guessing and checking is totally valid at this point. Could you graph these? Yes, you could. You would either have to get Y by itself here, or you could use a table to graph them. What two numbers add up to 30, and one of them is 3 times the other?
27.
27 and?
3.
Okay, which one's 27 and which one is 3?
Right-handed.
So X is 27 right-handed students, and Y is how many? 3 left-handed. Okay, so if you were to graph these two, they would cross at the point 27, 3. Okay. On your homework, some of them, most of the problems explicitly tell you to graph. So make sure that you graph, but it is okay to use guess and check to make sure that the answer makes sense. Okay. The last one should have been pretty easy because it was almost identical to the one we just did. Okay, a plant nursery is growing a tree that is 3 feet tall and grows at an average rate of 1 foot per year. So if X is going to be the number of years, what's Y?
Total.
Total what? Height. Okay, so let's write a sentence for that first sentence. A plant nursery is growing a tree that is 3 feet tall and grows an average of 1 foot per year. So y equals, what is my rate of change? 1x. So can I write just x? Yes. Plus, what's the initial height? 3. Another tree at the nursery is 4 feet tall and grows at an average rate of 0.5 feet per year. Okay, how would I write that as an equation? Good. You could change this to 1/2 x if you want, since if we were to graph this, that would be your rise and run. I'm leaving it as 0.5 right now because it's in the problem that way. The question wants to know, after how many years will the trees be the same height? What did we do if these both represent the height and I want them to be the same? Set them equal to each other. So x plus 3 equals 0.5x plus 4. Subtract 3 from both sides. So x equals 0.5x plus 1. Subtract 0.5x. So that's going to be 0.5x equals 1. And then what do I do? Divide by 0.5. Or 1/2. It's the same thing. So what's 1 divided by 1/2?
1.
No. 2.
2.
So after 2 years, the trees are exactly the same height. Okay? All right, the very last part, let's look at some vocabulary. So read along with me on the next page. A system of equations that has at least one solution is called consistent. So if it has at least one solution, it's called consistent. A consistent system can be either independent or dependent. Okay? So we have a consistent system. That means that it has at least one answer, and it's either independent or dependent. A consistent system that is independent has exactly one solution. So all of the ones that we have done so far have been consistent and independent because they all have had one solution. Make sense? They cross one time. So for example, the systems in problems 1 and 2 are consistent and independent. A consistent system that is dependent has infinitely many solutions. Okay, so meaning our systems that are consistent either have one solution or infinitely many. A system of equations that has no solution is called inconsistent. Okay, so that's all of our vocabulary. We will add this to our notebooks when we get into the rest of Unit 4, but right now we're just going to leave this up while we graph, okay? So let's look at problem 3. First equation, y equals negative x minus 3. Before I can start, let's make a set of axes. These numbers are small enough, I think we can go by ones for each one. Okay. Okay, guys, so looking at the first equation, negative x minus 3. What's the y-intercept? Negative 3, so go down 1, 2, 3, and put a point. What's my slope? Negative 1. That's the same as saying negative 1 over positive 1. So I'm going to go down 1, right 1. What if I wanted to add the negative to the bottom? That would be up 1, left 1. Okay, so you have to attach a negative to either the top or the bottom. And then graph it. So draw a line through it. Okay, let's look at the other one. Negative x plus 5. What's the y-intercept there? 5. So go up. 1, 2, 3, 4, 5. What's my slope? Negative 1. So I'm going to go down 1, right 1. Or I could also go the other way, up one, left one. So you attach the negative to either the top or the bottom of that fraction. They're parallel. Okay. So let's talk about this. Will parallel lines ever cross?
No.
No. So is there a solution to this? No. So this system has no solution, which means it is inconsistent. It's inconsistent because the lines are parallel and they will never cross. Okay? So in the homework it might ask you to explain why. That would be your explanation. The lines are parallel, so they will never cross. Could we have figured that out without actually graphing? Yes. What do we know about parallel lines? Slopes are the same. So if my two lines have the same slope, they're parallel, which means they will never ever cross, which means it is inconsistent. The lines are parallel, so they never cross. Okay. So then let's look at the next one. Let's graph y equals 3x minus 3. What's the y-intercept? Negative 3. So down 1, 2, 3. What's my slope? 3 over 1. So that means I'm going to go up 1, 2, 3, right 1. Or a negative over a negative is a positive. So I also could go down 3 and left 1. And then draw that line. Okay. Let's look at the next one. Guys, is the next line in slope-intercept form yet? No, not quite. So what can we do to get y by itself?
Divide by 3.
Divide everything by 3. So that's going to be y equals 9 over 3? 3x minus 3. Okay. It's the same, right? So I'm going to draw this so that we can still see the two colors, but they're the same line. Okay, what does that mean?
Infinite end of the world.
Okay, yeah, how many times is the purple line touching the orange line?
Infinitely.
Always, which is, lines go on for infinity, so there's infinitely many solutions here. So what type of solution is this? Is it consistent or inconsistent? Consistent, because there is a solution. Okay, but of our consistent solutions, look at your definitions. Is it independent or dependent? Dependent. So it's consistent and dependent. Because they are the same line. So there are infinitely many solutions. Okay? So what do we know? If the two lines are parallel, meaning they have the same slope, there is no solution because they never cross, so it's inconsistent. If the two lines end up being the exact same line, it's infinitely many solutions because they touch always, so it's consistent and dependent. Everything else that we did at the beginning of the lesson was consistent and independent because it had how many solutions? Just one. Okay?